everyone, welcome to my YouTube channel. Today I'm solving Leetcode question 37, Sudoku solver. It's actually a hard problem. Let's read through the problem. Write a program to solve a Sudoku puzzle by filling the empty cells. A Sudoku solution must satisfy all of the following rules. Each of the digits 1 to 9 must occur exactly once in each row. Each of the digits 1 to 9 must occur exactly once in each column. Each of the digits 1 to 9 must occur exactly once in each of the 9 subboxes of the grid. So the subbox consists of like 3 times 3, total 9 cells in total. The dot character indicates empty cells. So one example is the Sudoku board is like this. So there's already some numbers that are filled in at the initial state. So in this case, the input board is represented by a list of lists. So 5, 3, and then dot to represent the empty cell. So the output is basically you are trying to fill in the numbers 1, 2, 3 to satisfy those 3 rules. The 3 times 3 subbox refers to the 9 subbox on the grid. So 1, 2, 3, 4, 5, 6, 7, 8, 9. So this is actually a field board. So the number in red are actually the field number. So it says it's guaranteed that the input board has only one solution. When you fill in the digit 1 to 9 to the empty space. When you print out them as string. And then the empty cell is represented by the dot string. So to solve that, the idea is very simple. We just utilize backtracking. So for example, we are trying to fill out a number in the empty space. So let's check, okay, what numbers, let's say if we try to fill in the number, the digit 1 here. So there is no 1 occurred in the same row before, so we can fill in the 1 based on the rows. There is no 1 that's occurred in the same column before, so we can put the 1 here. There is no 1 occurred in the same 3 times 3 subbox, so within this subbox, there is no 1 occurred. So in this case, after checking those 3 conditions, we can put the 1 here. Okay, let's suppose we put 1 here. Let's try to fill the next empty cell. So we continue this process. Let's say, what if we figure out like what we cannot find a possible solution? What do? We backtrack to the previous step. Let's say we already filled the 2 empty cells, this and this, and then after that we find out we cannot find a possible solution. So we backtrack, let's say, to the previous step. So we take this field number out from the board and then replace it with a dot to indicate, okay, it's unfilled. And then we try to put other numbers in this position and then check if we can find a possible solution this way. So the overall idea is very simple. So let's try to code it up. So we need to have a row, and then we need to have a column, and then we also need to have a subbox. So equals default dict set, default dict set. Remember, we need to keep track of what numbers has filled in the same row and the same column and the same subbox before, so that we do not put the duplicate or redundant numbers. You want to make sure to satisfy those 3 rules. Each of the digit 1 to 9 must occur exactly once in each row. Each of the digit 1 to 9 must occur exactly once in each column. Each of the digits 1 to 9 must occur exactly once in each of the 9 3x3 subbox of the grid. So basically, those three default dict is utilized to keep track of if we satisfy these three rules. And then since this board is pre-filled with some numbers already, so the input board contains some number on the board. So in that case, we need to check what other positions, what positions we need to fill. So for all the positions that's already been filled before, so in the input board, we do not need to worry about them. We just need to fill out the empty cell. So in that case, we first need to know the position of the empty cell. That's why we track it in the toVisit. So let's try to loop through the board. First, get the dimensions. For I in range M, for J in range N, if board I, J is not which means this position IJ has already been filled. So this position IJ has already been filled. In that case, we add row I dot add J column J dot add I sub box. Okay, so we need to figure out how to represent the sub box. So basically, what we can do is the sub box I divided by 3, J divided by 3, take the integer portion, equal dot add I, J. So let's say if I equals 0, J equals 0, in this case, this tuple contains 0, 0. If I equals 3, J equals 3, then this indicates this cell. So in that case, it represented by 1, 1. So you can see in this way, the 9 subbox on the board are represented by 0, 0, 0, 1, 0, 2, 1, 0, 1, 1, 1, 2, 2, 0, 2, 1, and 2, 2. So that's kind of how we connected the coordinates I, J with the corresponding subbox on the board. So let's say here, the board is actually empty. That's the position need to be filled. So in that case, we add it to the toVisit I, J. Then let's code our backtracking function. So backtracking. If not toVisit. In this case, it means, okay, this board has already been filled. So we just return. There is no empty cell on the board left to be filled. We just return. Else, let's get the index I, J from the existing toVisit list. So we just take from the end. And then let's try to place a number on this position for the number for num in range. Okay, range. We are filling in 1 to 9, 1 to 10. So if, and then we are trying to place it here. Okay, I made a mistake. So when I'm trying to add the number, so I need to add the actual value instead of the indexes. So let me go back to the line 17. So when I'm trying to add it, so I need to keep track of what digit has already been used. So in that case, I need to add a digit to those 3 dictionaries I'm tracking. Yep. So in that case, if the num not, so remember this board, it contains the input in the string format. So in that case, string num equals string dot number. If this string num not in row I and string number not in column J, and this string number not in sub box I divided by 3. So since I'm utilizing this I integer divided by 3 multiple times, I just keep track of it here. So J equals I divided by 3, J integer divided by 3. So in that case, I can just replace with sub I, sub J. In that case, we place this, let's say we just try, for the integer from 1 to 9, we just check, okay, if this integer, let's select one integer from the range from 1 to 9, and then we try to check if this integer, if this number has already been placed on the board, on the same row, same column, or same sub box before. If not, then we can place this number on the board in this position ij, for this position ij. So in that case, let's try to place it on the board. So board ij equals, okay, we place this on the board, and then we add it to track this. Column J dot add string num sub box sub I sub J dot add this string number. Okay, after I add all of them, I also need to remove it from the toWidget, because we can place this, we can fill this position. So we just fill the position ij. So in that case, we just remove it from the toWidget. So to indicate we have already filled this position. And then we start our backtracking. We start placing the next position. Start filling the next position. We call this backtracking. Okay. So in this case, let's check if we can. We need to we need to check and indicate, okay, if this path down here is a path can lead us to a possible solution, or we cannot find a possible solution here, that we need to backtrack. So we let this one return a value. So if it can track down here, just return true. Else, we need to backtracking. We need to start backtracking. So basically, perform the similar process as we did before. So we replace this one with the empty cell indicator. We remove this one. So what does this mean? So let's go back to line 35. So the code from line 31 to line 35 is the code for placing this number on the position ij. So use this number to fill the position ij. And then after fill this one, we move on to the next one. So we call the backtracking function again. When we call the backtracking function again, it will go to the beginning of the function and then to check for the next empty cell, and then we are trying to fill that cell. Let's say if we can keep filling the board until we fill all the empty cell, in that case we find a solution. Let's say if we cannot, let's say starting from here, after we fill this position ij on the board, and then we call backtracking, it's ended up return false. So in that case, we know that putting this ij on the board does not work. So we start backtracking from here. So that's why we replace the field ij with the empty, and then start trying for other filling options. Previously, we may try, let's say, we can try fill the number 1 on the board, and then this number 1 has not occurred in the same row, column, or cell box before. So let's first place this number 1 on the board, and then call backtracking. But then we realize that when we call backtracking, we cannot find a possible solution. So in that case, we backtrack. Let's say we remove that number 1 from the board. So this option is to replace it with an empty cell. And then we try other options. Let's say we kind of have other numbers. So we can try the number from 2 to 9. So that's kind of the logic behind this. And then let's say after we try all the possible number options, we still cannot find the possible solution. That's in that case, we just return false. So let's try execute this one for. So basically, we complete coding the backtracking function. So I'm just calling it. Let me run the code. Oh, the answer is incorrect. So let me see what went wrong. Okay. Yeah, so I made one mistake. So if now to visit, that means we have already filled in all the empty cell. In this case, previously I just wrote return. Here, what I need to write here is actually return true to tell, okay, we find a possible solution. And then after I make the correction, so I can get the correct answer for this test case. Let me try to submit it. okay, this solution actually works. So since this one is a very complicated, hard problem, so let me go over the solution one more time. So the idea for solving this one is pretty simple. So you just track the rows, columns, and then the sub box. So that's why at the very beginning you create 3 default dictionary: row, column, sub box, to track, okay, for each row, what number has been put on the board before. For each column, what number has been put on the column in the same column before, and what numbers has been put in the same sub box before, in order to satisfy those 3 constraints. We also have a list called to visit. Basically, this one is to keep track of, okay, what are the remaining empty cells on the board that we need to visit. So for this line, it's just pretty standard for getting the dimensions. It's just my habit when I code the 2D grid type of problem. And then from line 14 to line 21, basically I'm trying to loop through the initial board. And then if a cell is not empty cell, then I try to add the number in that cell to the corresponding row tracker, column tracker, and sub box tracker to indicate, okay, this number has already been filled before. If this board is actually an empty cell, if this board ij is empty, in that case, I add index to the to visit list so that I can visit it later. And then I code my backtracking function. If my to visit list is empty, which means I have already filled all the empty cell, in that case, I just return true. I can find the solution. Otherwise, I check the index that's it in the end of this to visit list. And then I also calculate the corresponding indicators for the sub box. That basically is the integer divide for I divided by 3 and j divided by 3. And then after that, I just check every possible numbers. So basically, we can only fill in the number 1 to 9. So basically, in this case, I just check the number 1 to 9. Remember, I need to convert it to string format because that's kind of how the input board is formatted. And then I check if this string, if this one has already occurred in the same row, if this has already been used in the same column, or if this one has already been used in the same sub box, basically to satisfy those 3 constraints. If not, then I can put this number in this position. So I fill the board ij with this number, and then add it to the corresponding row, column, sub box tracker, and then I remove that from the to visit. So in this case, I indicate, okay, I have already visited the position ij, and then I starting filling the next empty cell by call the backtracking function recursively. If somehow I can reach a solution, then I will just return true. Otherwise, it indicates, okay, by placing this number on the board, I cannot find put this number in this position. I cannot find the possible solution. I cannot find a solution. In that case, I start backtracking, and I start backtracking from this position. So I take this number out of the board ij by replace it with the empty cell indicator, the dot, and then remove it from the corresponding row, column, sub box tracker, and then add back this one to the to visit list to indicate, okay, this one is empty, I need to visit that. And then I go back to the for loop and then try other possible number options. For example, if I previously tried 1, and then there's no possible solutions going down there, then I can try fill this position ij with another number. So that's kind of the entire logic for this backtracking function. After that, I just need to call it. So that's kind of pretty much the solution. If you like my video, please don't forget to subscribe to my YouTube channel. Thank you.